Hello everyone. In today's session, I will discuss about the shear force diagram and bending moment diagram, which is the one of the important topic for designing of beam or structural member. These are the following learning outcome of the today's session. After this session, you will able to determine the effect of external load such as shear force and bending moment at any section of the beam for given loading condition. And the outcome of this session is, after this session you will able to draw the shear force diagram and bending moment diagram of the beam for given loading condition. Now let's recapitulate the prerequisite which we have already discussed in the previous lectures are: first, the condition of equilibrium. The condition of equilibrium, that is the static equilibrium condition for different types of force system. This one is the condition of equilibrium for coplanar non-concurrent force system. That is, summation of forces equal to 0. The summation of forces in y is equal to 0. That is, the summation of all the vertical forces should be 0. And third is the summation of moment about any point or about z-axis equal to 0. Next is the system of forces. We have already discussed in the previous lectures. There are various types of force system like coplanar, non-coplanar, concurrent, non-concurrent, collinear, etc. Next is the types of beams, supports, loads, which we have already discussed in the previous lecture. Next is the types of stresses like the normal stress and shear stress. And the last one is and it's very important, how to draw free body diagram. That is an isolated diagram which represents all the forces acting on the body. All the forces means that is the external forces as well as the reactive forces acting on the body. This concept is very important for finding the reactive forces, that is the forces acting on the supports. Now focus on the main topic, that is the shear force, or we can say simply shear in beam. So shear force at any section of a beam is equal to the algebraic sum of all the vertical forces which is acting perpendicular to the axis of the beam, either to the left or to the right of the section. Now just consider a example. Through this example you will able to understand the concept of shear force. A simply supported beam having point load P acting at point C. The length of the beam is L and the point load P is acting at a distance A from left end and the distance B from the right end. Now first find out the value of shear force at point A, and after that we will find out the value of shear force at point B, and finally the shear force at point C. The shear force at A and B, we need to find out the reaction forces. By applying the condition of equilibrium, that is a condition of static equilibrium, we will find out the value of reaction force RA and RB. Now the value of shear force at point B. At point B, the shear force is RB and it's negative. So that is the value of shear force at B is minus P into A by L. And the shear force at A is equal to the value of reaction force at A, that is PV by L. Now the most important point is the value of shear force at point C. So at points, to find out the value of shear force at point C, we need to find out the value of shear force just at point C, that is just right of C, and the value of shear force just left of C. So for that purpose we need to draw a section line just before the point C and just after the point C. If we consider a section line just before, that is just before means we are considering the distance or section from B. If we consider section here, then the value of all the vertical forces will be, that is RB. So that is minus PA by L, minus PA by L. And if we consider a section line just after the point C, then the value of shear force, the sum of all the vertical forces, will be RB, that is minus RB, and plus RB, right? So the value of shear force just left of C equal to minus PA by L plus P. That is, and very important point you have to consider, the sign convention which I have followed in this example is the shear force which is acting upward, consider negative, and downward is positive. This is the sign convention which we have assumed for this example, right? So you can assume any assumption, that is the downward is negative, upward is positive, whatever you want to assume you can assume, it's up to you. So in this example we have assumed that there is a force which is acting upward is negative and the force which is acting downward is positive, right? So this is the method to find out the shear forces at any section of a beam. If A equal to B, that is the point load P acting at equal distance from both ends, then in that condition the value of shear force at B will be minus P by 2, and the value of shear force at A equal to P by 2, which is equal in magnitude but opposite in direction of shear force which is acting at point B. And the value of shear force at point C, for that purpose we need to find out the shear force just right of C and left of C. Just right of C, the value of shear force will be minus P by 2. So there are two values of shear force at point C, that is just right of C, that is minus P by 2, and just left of C, that is P by 2. To understand the shear force in more detailed, now consider one more example. This is a simply supported beam, this point having the pin support and this point having the roller support, and there are two concentrated loads are acting 10 Newton at a distance of 1 meter from A and 5 Newton force which is acting 2 meter from B, and the length of the beam is 4 meter. To find out the shear force at different points of a beam, for that purpose first we have to find out the value of reaction forces at point A and at point B. For that purpose we have to apply the concept of equilibrium of the beam. This is the conditions for equilibrium of the beam. This is the coplanar non-concurrent force system, right? Because all the forces are acting in the same plane and their line of action are passing through the different point of application. So it's a coplanar non-concurrent force system. The condition of equilibrium is summation of forces along x equal to 0. Second, the summation of forces in y direction is 0, and moment about any point in the plane should be 0. This is the condition of equilibrium. Now first we have to draw the free body diagram of the beam. It's a hinge support or pin support. So there are two reaction forces, RAV and RAH. That is a reaction force in horizontal direction and reaction force in vertical direction. Next, the point load 10 Newton, which is acting at a distance of 1 meter from A. Next is the 5 Newton force, which is acting at a distance of 1 meter from point C. And here is the roller support, that is reaction force RB in upward direction at a distance of 2 meter from B. Now the summation of, first apply the condition of equilibrium, the summation of Fx0. So RAH equal to 0. This implies the value of reaction force at point A is 0. Now the next, summation of Fy equal to 0, that is RAV plus RB equal to 15 Newton. Equation number 1. Now apply the condition of moment, summation of moment about any point. So first let's consider the moment about point A. About point A, or we can say the summation of moment about a point A or the axis which is perpendicular to this notebook is equal to 0. So that is 10 into 1. The moment of 10 Newton force about point A is 10 into 1, and the direction of the moment is clockwise. So we have assumed that the moment, clockwise moment is positive, plus 5 into 2. The distance of 5 Newton force from point A is 2 meter. Next, RB into 4 equal to 0. So we have find out the value of RB, reaction force at point B, is 20 by 4, that is 5 Newton, and hence the value of RAV equal to 10 Newton. So we have find out the value of reaction forces at point A, and at point B. Now we need to find out the shear force. Shear force at different sections of the beam, right? So for this purpose, now consider the free body diagram RAV, which is which is 10 Newton, and it is acting upward. RAH is 0. 10 Newton force at point C. RB acting upward is 5 Newton, and at point D is 5 Newton, right, which is acting downward. Now first find out the value of shear force at point B, that is value of shear force at B. The value of shear force, that is the at this point, the sum of all the vertical forces acting at point B, right? So this is the section line. By using the section method, consider a section line which is passing through the point B. The value of all the vertical forces is RB. Now first we have to assume some sign convention. For this problem, I have assumed the upward shear force is positive and downward shear force is negative. This is the sign convention which I will follow in this example. This is the section line, right? So the shear force will, if we consider a section here and the shear force is acting right of the section and acting upward, then it is considered as a positive, and if it is acting downward, then it is considered negative. You can assume whatever the assumption you want to follow, but it should be uniform throughout the question. So here RB is positive. The value of RB is 5 Newton. That is the value of shear force at point B is 5. Now the shear force at point D. So here it's a very interesting point. At point D, the value of shear force at point D is very important. To find out the value of shear force at point D, we need to consider the section line just before the D point and a section line just after the point D, right? So what we are doing, we are considering a section line at a distance of x, section line xx at a distance of x from B, right? So for finding the value of shear force at point D, we have to consider 2 points. The value of shear force at just before right of D. So this is the section line. So just before the D, what we have to consider, this is the scenario. We are standing here. The sum of all the vertical forces is RB only, and it is acting upward. So this is the value of shear force just before the D point, that is 5 Newton, which is positive, right? Now the value of shear force at just after or left of D point, and this is the case. Now we have to consider RB as well as the concentrated force which is acting at point D. So this is RB, which is acting upward. We have assumed RB, the upward force is positive, and force which is acting at point D is downward, so it's a negative, so minus 5. So total value of shear force just left of D point is 0, right? And similarly, we can find out the value of shear force at C. So just right of C just right of C, that is RB minus 5, that is 0, and the shear force at just left of C will be RB minus 5 and minus 10, that is minus 10 Newton. And finally, the value of shear force at point A will be RB minus 5 minus 10, that is minus 10 Newton, or RA minus RA, that is minus 10 Newton, right? I hope you will able to solve this kind of problems, and if you have any doubt you can ask. Thank you.